Hello, pre-calculus folks. This is Mr. McAllen, and this is the review for your test on Tuesday. Or this is a review for your test whenever you're going to take it. So we're going to start off with the multiple choice questions. And you can see here we have cotangent times secant. Which one is this equivalent to? So you rewrite cotangent as cosine of x over sine of x times secant, which is 1 over cosine of x. They cancel because you're multiplying, and you're left with 1 over the sine of x. You would choose choice D. The next one, sine squared of x minus 1 is equivalent to, well, sine squared plus cosine squared is equal to 1. So sine squared of x minus 1 will be equal to, well, I'm looking for negative cosine squared of x. Since there isn't one, I'm just going to put like choice B here and put my own answer for, put that negative in front. Sine squared of x minus cosine squared of x. There is no answer for this one. All you can really do is FOIL that. The only thing that you can say is sine squared of x plus cosine squared of x is 1, or negative sine squared of x minus cosine squared of x is equal to negative 1. There's no in between. There's no answer for this problem. Sorry about that. Must have been a typo. Let's just say we changed it to that, then we'd be able to say that's the answer. Next one, simplify any 5. Well, for cosine of x, you could write sine of x over tan of x. I'm sorry, sine of x over cosine of x for tan of x. And then this 1 over sine of x. And hopefully you see that everything cancels and we're left with 1. Here we have a compound fraction, sine of x over cosine of x over sine of x. So hopefully you see that the numerators cancel and we're left with 1 over cosine of x. Next one, we have sine of x over sine of x over cosine of x times cosine of x. They cancel, and they cancel because they're in the numerator each, and that just equals 1. This one is pretty easy. It's secant squared of b minus 1, and we know that secant squared of x, tangent squared of x plus 1 equals secant squared of x. So secant squared of x minus 1 is simplified to be tangent squared of x. On this next one, negative 1 would be the answer, and that would also be coming from rearranging this identity. This one is just simply foiling. I got tan of x plus 2, tan of x plus 1 in the numerator. In the bottom, I can FOIL that. Tan of x plus 1, tan of x plus 1. They cancel, and my end result is that quotient. Moving along, factor and simplify. Well, if there are two terms, take out the greatest common factor. So I just take cosine of y out in front. On the next one, this is just using x method factoring. Multiply, well, it's a simple factoring too. Cosine of y minus 3, cosine of y plus 2. On the next one, this is difference of squares. On the next one, this is just x method factoring. What multiplies to give you negative 6 adds to give you 5. So this would be this would be 3 sine of y minus 1, I believe, and sine of y plus 2. And that would give you your factors needed to multiply that trinomial. This is a difference of squares. Sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x. You're not done yet. This part is 1, and this part is difference of squares again. Sorry, cosine of x, sine of x minus cosine of x, and now we're done. This I don't think it's factorable. I'm going to pause it and just check it out, but I don't think it's factorable. Okay, I'm back. Personally, I think I made a typo with this problem. I think this should either be sine of x or sine squared of x, so I apologize. I'm just going to not do this problem. I'm going to say it's a typo. So please ignore that. If you've tried it, I apologize for your time. The last part is we have these identities to do. So this might take a little while. Well, the first one is just splitting fractions. So I'm just going to split this into 1 over sine beta plus 1. This becomes cosecant beta plus 1, and the identity is done. So basically this was splitting fractions, and this part here was dividing and reciprocal. The next one is these two cancel out. They're reciprocals of each other. So we have cosine squared of x, and then we just rewrite that as 1 minus sine squared of x. So for reason 1, we say reciprocal times itself equals 1. So reciprocals, that was a good spelling job. And then the second reason is Pythagorean ID. So that was a nice easy problem. Next one, we're just going to use, I've got cosine of x plus sine of x. This is sine of x over cosine of x. So the first reason is a quotient ID. The second one is going to be when I'm going to add these fractions because I have cosine squared of x over cosine of x plus sine squared of x over cosine of x. And what that results in is when you put the two of them together over one fraction, you have cosine of x in the bottom and we have 1 in the top, which is going to be secant of x. The reason for the second reason in this proof is adding fractions. And the third reason is Pythagorean identity, and that's where we basically said that is equal to 1. And then the last part, the fourth part, was a reciprocal ID. So now we look at number 4 and 5 are the big questions that will take us some time. Actually, 5 doesn't. 5 is pretty easy. I'll do that first. The sine plus cosine, sine squared plus cosine squared is 1, so we replace it with a 1. I have tangent squared of x. So the first reason is Pythagorean ID. Second reason is we're just going to call this secant squared of x because that is again, Pythagorean identity. The last one is actually a pretty interesting problem. It might take a little bit of a while to get through. So I'm going to work on the left. And on the left, I'm going to do conjugate multiplication. So I have 1 plus sine of c over 1 minus sine of c. And I'm going to multiply everything by the conjugate, top and bottom, 1 minus 1 plus sine of c over, that's the conjugate of the bottom, 1 plus sine of c. So now when I multiply this, I have the top is going to be 1 when I FOIL it. So this is the first step is conjugates. The second step is 1 plus 2 sine of c plus sine squared of c. On the bottom, I'm going to have difference of squares, so I'm going to end up getting 1 minus sine squared of c. So this is just foiling, multiplying, whatever you want to say. The next step, I have 1 plus 2 sine of c plus sine squared of c. That's all over. I'm going to change this to cosine squared of c. This is where it gets interesting. I'm going to have 1 over cosine squared of c plus 2 sine c over cosine of c. I'm going to write cosine of c again for that cosine squared part. And then the other one is going to be sine squared of c over cosine squared of c. This step is breaking fractions or separating fractions. So the first part is going to be secant squared of c. The second part is going to be, I have 2 sine of c over cosine of c is tangent of c. And then the cosine of c in the bottom is secant of c. The last part is going to be tangent squared of c. I'm almost finished. Now, this is going to equal, this is like a perfect square trinomial. And if I look at the factors, the first part is going to be secant of c of both binomial. The last part will be tangent of c of both binomial, and they're both going to be plus on the inside. Now, when you look at what we're trying to prove here, we are going to, you notice that it's tan of c plus secant of c quantity squared, which is what we got. I just have it in reverse order, but so secant of c plus tangent of c quantity squared is the same as tan of c plus secant of c quantity squared. And that is all there's to this problem. This problem was a pretty long problem, pretty long and drawn out, pretty difficult to do. And you know, basically what we did in step 4 was in the first part here, we had used a to go to this step, we used a reciprocal. For the middle part, we used a quotient by changing that to tangent, and a reciprocal. And then the last part, to turn the tangent squared of c, that's a quotient identity again. So, you know, basically we use a whole bunch of different recognizing identity properties here. And on the last part, when we saw that we had a perfect square trinomial, that was just basically a factoring technique. So the last part was factoring. Hopefully this video has helped you understand how to get through that review. Tomorrow you have in class, and I hope you guys give it a good shot. And, you know, we'll have the test on Tuesday or the next time we meet. And good luck.